All right, so let's take a look again at the basketball perimeter problem. This is where we're at. So my plan is to finish 2.6 and 2.7, do some review. I'll look at the practice exam. Hopefully you've already taken a look at the practice exam. I don't know if we'll have time for all that. We'll see. And then we'll take the test, 12, 1205, something like that. All right, so they're asking about perimeter. What's the formula for perimeter? Yeah, perimeter is 2L plus 2W, right? We talked about that, width and length to go all the way around any rectangle, huh? 2 widths and 2 lengths. And then you just plug in. Now remember, even though right now I've got like P and L and W and stuff, eventually I'm going to just have X and numbers, right? So remember, I'm trying to boil this down to make it just as easy as I can, because I know it's not easy. Word problems are hard. Oh, Roberto's hours are up. Thank you, Roberto. Yeah, so this is Roberto. You've met him a couple times, right? This is our assigned tutor. He's here for you guys. He's the best option for tutoring, right? There's really 3 options for tutoring on campus. I don't know if I've made them all clear. I haven't even said them, have I? So one of the options, there's tutoring at the math science building. So there's tutoring over there at the math science building. Hours are listed. The hours for that are listed outside the offices there. Most of the offices down there, offices in the basement. Offices down in the basement level, the bottom level of that building. That's where they put the math teachers, because we're the most important people. We're the most important in the basement. All right, so down there, if you go in the basement, any of the offices outside, they have hours for math tutoring right there in that building. So that's a good place to go for help, because there's usually a math teacher there and 1 or 2 tutors, and you can get help there, and the hours are listed. If you want to do that, go over to the math science building, go down to the basement, outside my office, or pretty much any of the offices. You'll see the hours for that. That's option number 1. And then there's just tutoring in general. There's general tutoring, like 9 to 5 or 8 to 5. Do you know, is it 8 to 5? 9 to 5? Something like that.
8 to 5. And
8, and they start early.
Friday.
Yeah, except for Friday.
Friday they close early.
Yeah, Friday they close early, but 8 to 5 the other days. In LI 134, there's always tutors there. Problem with that is, and the other one is you might get shown different methods, and that can be confusing, you know. So Roberto's the best option. So here's your best option. He's the ETC, extending the classroom. He's like an extension of our classroom, because he checks in with us every week. He's worked with me last semester as well. So he knows the ways I do it. So he'll show you the exact same ways. He's going to have all the practice exams right there with him. So he's the best help. If you can go to his hours, you'll get the most helpful help. So there's 3 options for that. Thanks, Roberto. All right, so let's go back to solving perimeter. So remember, on word problems there, trying to boil it down and make it simpler. One of these, well, first off, perimeter is 96, right? So let's just pop that in for P. Now, what am I going to do for the L and the W? Pretty much, one of them is going to become X, and the other one is going to become an X formula. And it really doesn't matter which one you do which, even though technically it sort of does. You can work it out in the end. So what I'm saying, as clear as I can, almost every one of these word problems is going to come down to 2 things you don't know. In this case, it's L and W. Some of the other problems, it was something else. But there's almost always 2 things. Just let the first one be X. Nothing harder than that. Just simple X. And then the other one, let that be some kind of X formula. You know, like X plus 3 or X minus 7 or something like that. Every time in these word problems. Simple X, X formula. Every time. So I'll just and I don't even care which is which. So I'll just let the first one be X. I could have made the second one X. Doesn't matter at all. Now the 2 is still there. The 2 is part of the original thing. Now, the other one has got to be some X formula, right? Let the first one be X. The second one would be some kind of X formula, like X plus 3 or X minus 2 or X times 7 or what. So how do you know what that is? Well, that's the trickier part. Look at the rest of the words now. What does it say? 6 more than twice. 6 more, 6 added to twice. That's kind of tricky. 2x plus 6. Everybody see how I came up with that? Because 6 more than twice. 6 more than twice means 2x plus 6. 6 added to 2x. Everybody see that? So I let one of them be simple x, the other one be an x formula. That's what we do every time. Once you've got that, now you can solve it, right? It's all just a big old equation with x. So let's distribute over here through the parentheses. That'll be what? 4x plus 12. We good to there?
Yeah.
Now, these x's are on the same side, so they just combine together, right? So 96 is 6x plus 12, like that. So far, so good. X is saying I want to be alone, like he's always saying. How do we get x alone?
Subtract 12.
Subtract that 12. So let me bring it up here. So 96 minus 12, what's that? 84 is 6x, right? This is 84. This is 6x. What's the last step? Always divide. Whoops, divide. That's a funny looking 6. Divide by 6. Is that what it is? 14? Thank you. So x is 14. Now, x is not the same thing as giving the answer. So x is 14, but they're going to ask me for length and width. How does x is 14 turn into length and width? You guys with me so far? Every word problem, you'll get x at the end, but then they're asking you something like, how old is Susie and how old is Mark? Or what is length and what is width? How do you figure that out? Best way, there's a lot of ways, but I think the easiest way is just go straight back to the words. Look what it says here. Length is 6 longer than twice the width. Length is, let me just write that. Length is equals 6 added to twice. Twice what? Twice the x. Twice the 14. Everybody see that? 6 plus 28. What is that? 34? Is that on the screen? Can you see it? No, it's not on that. Oh, the projector. All right. Let me find some more room for that. Let me just scribble it in down here. So, okay. So, length. And I'm just going straight off the words, right? I'm just reading the words. Length is 6 meters longer. 6 added to twice width. So, length is 6 added to twice x, which is the formula we had right here, right? I just put the 6 in the front. It doesn't matter which order. But instead of x there, I now know what x is. X is 14. So length is, if you work that out, it's 28, 34. So length is 34. So if the length is 34, what must the 14 be? It must be the width. And now we've got it. So everybody see how I wrapped up that word problem? So what you do when you get x at the end of a word problem, how you finish the very end is you go back to the words and just do exactly what they're saying. Length is 6 meters longer added to twice width. Length equals 6 added to twice the answer I got. And that's 34, and that's length. It said that's length. So then the other one must be width. And we're done. Is that good? Felt like you could do that in exam number 2 in a couple weeks. All right. Let's see. Where are we? Okay, so 64.68 during a 40% off sale. Okay, so I want to help. What they're going to do now is they're going to give us a bunch of problems where they increase or decrease a price. What section are we in? 2.6. Try to, yeah. Here's back in my notes for a good, clear way to say it. All right, so let me help you with this. So basically, when something's on sale, does that increase the price or decrease? Decrease. So let me give you a formula for percent decrease. They're going to give you a few problems in this section that are percent decrease. They're also going to give you some that are percent increase. We'll get to that in a minute. So percent decrease, what you're going to do every time is you're going to take x plus percent x equals new. That's what we're going to do. You guys tracking with me there? So that's the, I would write that, before exam number 2 in a couple of weeks. I would write that on my 3x5 card. It is actually 2 weeks from now, or 2 weeks from a week from Monday. Exam number 2, it's not that far away. So write that in your 3x5 card. So let's do what it's saying now. So x plus percent. Now what goes in the percent? Well, it's 40%, but remember we always turn those into decimals, huh? 0.40 x equals the new price. 64.68 was the new sale price. Tracking with me on that? Now we just solve for x. It's easier said than done though, but let me hold up for just a minute. So anytime you have, oh, did I say decrease?
This is regular.
Decrease should be minus. I'm messing up. The increase is plus. That should be minus. So let me go back and erase these. It should be minus, sorry guys. Decrease is minus. Increase is add, right? Okay. So here's what we're doing. So what x is, well, let me solve it first, then I'll give the logic about why it's true. It is right, but let's get the answer, then I'll show you why this is right. So, Amy paid $64.68. That's the new price she paid. That's not the regular price, is it? That's not the regular. Shoes are normally more, right? But she paid, this is the new price because they're on sale. Does that make sense? I need to solve for x. X will be the regular price. Because whatever the regular price is, then they subtract 40% of the regular price. And they get the new price. So I got to find x. Now how do you solve that for x? What's my next step? What do I do with these guys? How do I combine them? Right, you're right. But how do I do that? Subtract. And subtract what? Good job. Yeah. Think about it. There's really a 1 here, huh? Remember, it's like 7x minus 3x, for example. That'd be 4x, right? You just subtract the numbers in the front. So it's the 1. It's the understood 1. Take away the 0.40, which is 0.60, or just 0.6. Everybody see how I did that? You just subtract the numbers in the front, and there's really a 1 in front of that first one. It's just like terms. But it's weird looking because you don't see the 1 at first. Is that good? And then just divide by, last step is always divide, right? Divide by the 0.60. X equals, somebody got the number on the calculator there? 100 and something? 107.8. 107.80. Like, anybody else getting the same answer? Is that it? No? Nobody? That looks right to me. It looks reasonable. I can't do it in my head. Anybody else got the same answer? Yeah, good. So the regular price of the shoes was $107.80, which no one should ever pay that much for shoes. I've never paid that much. Maybe my wife has. I don't know. But I never would. And then the sale price was the 64, which still seems high to me. Anyway, yeah. Yeah. I took 1, which is really 1.0, and subtracted 0.4. Like on a you can do it on a calculator. I subtracted and got 0.6. Like $1 take away 40 cents is 60 cents. Does that make sense? Because there's really an understood 1 in front of that x. And you remember you subtract whenever you have 2 x's being subtracted, you subtract the numbers in the front. Just like if you had, 7x minus 3x, you would subtract them and get 4x. You combine like terms. So what I did there is I really just took the 1, like $1.01 minus 40 cents is 60 cents. I just subtract.
Even if you were just to put 1.0 in the calculator, it needs to be 1.00?
No, even just regular, it'll work with anything. Just regular 1. You don't even need to put a decimal. Yeah, I'm just showing this for more detail, but just put in 1. It'll work fine. Other questions on that one? Does that make sense? How we got that? So this formula then is what you want to use anytime something's on sale. Anytime they're decreasing in price. Now, why logically does that formula work? Let me just appeal, because I don't want to just have math be like, steps that don't make any sense. It's not interesting and it's harder to remember that way. If I asked you, if I said, hey guys, there's shoes are normally $107.80, pair of shoes, outrageously priced, at $107.80. And I said, hey, can you mark that down, put it on sale 40% off? Every one of you could do that, huh? How would you take 40% off of that? Just think what you would do. Yeah, you would multiply by 0.4D, or 0.4, same thing, whatever, right? But that wouldn't be the answer alone. You would get that answer, whatever your calculator says, and then do what? Deduct it from the original. Well, you see what this is? This is like x minus x. The 107.80 is the x times 0.40. Do you see why this formula is right? That's what you do when you deduct a price. You take the original price minus whatever percentage of the price. That's how you do it, huh? Just like you would do with the 107.80 times 40, but subtract that from the original, huh? That's why that's the correct formula to give you the new price. That's what we do when we deduct, right? Does that make sense? Questions on that? All right, let's. Okay, so employee's new salary is $23,100 after a 5% raise. 5% raise. So is that a percent increase or a percent decrease when you get a raise? That's an increase, huh? So for percent increase, it's the same exact formula that we had for percent decrease, except there's an add in the middle instead of a subtract. Everybody seeing that? Right, the decrease just had a minus because when you decrease, it subtracts, huh? It lowers the price. When you increase, you add. You add to the price. Okay, can you do the same thing, guys? Try it. The rest is the same. See if you can do the rest from there. Give you a second to try that one. Okay, so x plus, what's the percentage? What do I put in the percentage slot? Do I put 0.5? Is that right? 0.5, huh? Because it's always got to go back two places, huh? It's an easy mistake to make. Watch out. So 0.05, like that. We good so far? And then what's the new? That's the 23,100, huh? That's the new salary after the increase. We good to there? So far, so good. Okay, can you solve it from there now? So now add these. What number is going in front of this x?
1.
1, huh? So, whoops. That was not correct. I missed. So 1 add a nickel. $1 plus a nickel. 1.05, huh? We good? $1 plus 5 cents is $1.05. Good on there. And now what's the last step always? Divide, huh? Last step's always divide. What is it? 24?
22,000.
Oh, 22? Oh, I'm confused. Yeah, it's got to be lower, huh? 22 what? Straight. Okay, 22 straight. So her salary before the raise was 22,000. She got a raise and it went up to 23,100. Does that make sense? Went from a lower to a higher. So that makes sense. Is that good on that? Questions I can answer? All right. I have to fool around with all these words. Okay, hospital parking charge is $2.50 for the first hour, $1.25 for additional hour. A weekly pass costs $48, unlimited 7 days. Each visit Johnny makes 2.5 hours. What's the minimum visits for which buying a parking would be less expensive than paying each time? Oh, it's not, you can't even see all the words up there, can you? This is confusing. All right. I would just do it. I'm not going to do anything fancy. I'm just going to say, look, Johnny's doing 2.5 hour visits, right? 2.5 hour. How much is a 2.5 hour visit going to cost? Parking, I mean. Well, it's $2.50 for the first hour, and then it's $1.25 for each hour after that, or part of an hour. So it'll be $1.25 twice, won't it? Right? Because 2 hours is one whole hour, another whole hour, and then half an hour. So this is the first hour, the next hour, and then the half hour. Right? Isn't that what the words are saying? It's $2.50 for the first hour. It's $1.25 for every hour after that, or even a part of an hour, even 1 minute. Does that make sense? So that would be, add that up, what is that, $5? Yep. So it's for every time Johnny makes a trip, it's going to be to park for 2.5 hours at the hospital. It's $5 in parking. Good so far? Always kills me when they charge a lot of money when you go to like Disneyland or something. You're paying a ton, or a Giants baseball game, or the Dodgers game. I went to the Dodgers game last year. Paying a ton for these seats already. Then it was our anniversary. I took my wife to a Dodger game, and we arrived, and then they're like, $20 for parking. Haven't I given you enough money already? Just take it all. All right. Anyway, kills me. All right. So $5 there, right? Does that make sense how I figured that out? It's $2.50 for the first hour and $1.25 for each hour or part of an hour after that. So for 2.5 hours, it's going to be $5. All right, so $5, and then a weekly pass of 48. So if he's going to buy a weekly pass for $48, would that be better? For unlimited parking for 7 days? How much is it going to cost Johnny for 7 days?
35.
Yeah, that would only be 35. Wait, so that's not better. What are they asking? What is the minimum number of days for which buying a pass would be less expensive? Oh. Minimum number of days. So he should not buy the pass, right? It's an easy question. So how many days would he need to come? I mean, you can only come 7 days in a week, but I don't know why. It's kind of a dumb question. Do you see if he even came 9 days, which I don't know how you'd come 9 days in a week. That's why it's a dumb question. But let's just say he came 9 days. How much would it cost him? $45, right? It'd still be better to not buy the pass, right? Because the pass is $48, right? So how many days? But if it's $5 a day and he came 10 days, then that would be $50. Then it would be better to buy the pass. Are you with me? Do you see? This is kind of a dumb question. So if he came 10 days, it would be better to buy the pass. That's what they're asking. How many visits would make it better to buy the pass? 10 visits. If he visited 10 times during the week, that would cost him $50, and he would be better off buying the pass. 10 or more visits, right? I just simply found out what would go higher than $48. Because the pass is $48, so if you want the pass to be cheaper, you got to go higher than $48. So $5 a time times 10, 50, that's more than 40. That's the first one. Whereas I did 9 days, that was still under 48. So I did one more day, and I went, oh yeah, that's more than 48. So yeah, if you come 10 times, Johnny, it would be better to just buy the $48 pass. So that's the number of days, number of visits. So if Johnny knows he's coming 10 times or more, he would be better off buying the pass, right? Does that make sense? It's just a lot of words there. I'm not going to put one like that on the test. That's kind of a weird. How many, all the angles in a triangle, does anybody remember? What does it add up to be? 180. You do remember. All right. All angles add to equal 180 in a triangle. Yeah. All right. So what are they saying? B is 4 times A, and C is 17 less than 5 times A. All right. So when they start talking this way, so there's angle A, angle B, angle C. It says B is 4 times A, so B is 4A. You with me? B is 4 times A. B equals 4A. And C, can you do C? C is 17 less than 5 times A. Let me let you write that out. C, so we already got B. B is 4 times A. B is 4A. Equals C is 17 less than 5 times A. 17 less. So write right here the formula for C. They're telling me what to put next to C. They're saying C is 17 less. Yeah, think about this, guys. If I go 17 less than 50, you know that means subtraction, huh? And who comes first in the subtraction? The 50. 17 less, that phrase, that English phrase, means the 17 goes at the back, doesn't it? It's really an English thing more than it's a math thing. So you have to realize whenever you read, such and such less, that goes at the back. That's just what the words mean in the English language. 17 less means 17 is subtracted at the back, not the front, right? Just like is the case for 17 less than 50. 17 goes at the back. So when they say up here, 17 less, that 17 goes at the back. What goes at the front? 5 times A. 5A. Does that make sense? So, okay, great. That's all well and good and everything. So what do I do with all that? Well, now we know that they all add up to be 180, don't they? So that means A itself plus B plus C have to add up to be 180. We'll leave A as A. What's B? 4A. What's C? 5A minus 17 equals 180. So we got A, 4A, and 5A minus 17. That's A, B, and C. Oops, it's off the screen there for some reason. Let me try that again. Right, so we have A, 4A, 5A minus 17 is 180. Everybody good with that? See how I'm coming up with that? Right? We have plain A, we have the B formula, and then the C formula. That's A plus B plus C, all in terms of A, equals 180. Now we just solve that. Yeah, exactly. Because this is 1A again, right? Whenever there's not a number in the front, it means 1. 1 and 4 and 5 is 10A, huh? 10A minus 17 is 180. How do you solve for A?
Add 17 to both sides.
Yeah, add 17 to both sides. Oops. And we get what? 10A equals 197. And last step's always dividing, huh? That's not going to come out nice, though. What is it, 19.7? Do they say, yeah, they let me do it. So that's A, and they're going to also ask me for B and C. How do I get B and C? Just plug them in, huh? So A is 19.7, and then B is 4 times that. 4 times 19.7, whatever your calculator says.
78.8.
78.8, is that what it is? Okay, thank you. 78.8. And then C is 5 times A, 5 times 19.7, minus 17, which equals, anybody got that one? What's that? 81.5. Thank you, Roberto. 81.5. A, B, C. We good on that? So we did the work. We found A. Oh, that was off there. Oh, yeah, that's good. Okay. So, yeah. So we found A. 19.7. And we plugged it in for B and C. All right. We better keep moving. This will be... Okay, so try that. Let me give you a minute. Rather than me just diving in and doing the whole thing, let me give you a second. Sarah's investment in stock grew 22% to 366. How much did she invest? So this is like one of the ones we did about 20 minutes ago. Look back to your notes. Think about it. You see it's a percent increase, isn't it? It's just like the one where the person got the raise, right? So stocks going up or somebody getting a raise at work, that's a percent increase. So go ahead and write the percent increase formula. We had it a few problems ago, right? See if you can, yeah. It'll be the same as that. Yeah. Yeah. You got it. Oh, no, divide. Last time we divide. Right, that's to get extra to divide. So as soon as we see like stocks going up or somebody getting a raise, they'll also do tax. They'll say such and such price and then how much with tax. Those are all increases, right? Those are all different ways of saying percent increase. So when you see them saying percent increase, you right away think, okay, you're going to have that formula on your 3x5 card week after next, right? Like that. X plus percent X equals new. If they decrease, if they put something on sale, then it's a minus in the middle, huh? So again, have that on your 3x5 card for exam 2 week after next. And then you go, okay, X plus percent X. What is the new price? 366. And then the percentage, 0.22. Make it a decimal, huh? 0.22. We good to there? And now there's really a 1 in front of that one. $1 plus 22 cents, $1.22. Last step is always divide. Is that what it is? Just 300 right on? 300 right in the money? Good. Is that making sense? Getting the hang of those percent increase, percent decrease ones? They'll give you quite a few on the homework. Questions I can answer? So the original price was 300 was lower, and they increased it up to 366. Okay. Employee's new salary after a 5% raise. Try that one. Same kind of thing, huh? A raise, stocks, all percent increase. 12, 12.5. Sure. One. All right, so this is a percent increase. And so that's X plus percent X equals new. So the percentage is 05. The new price is 26,355. We good to there? Like that. And there's really a 1 here, so this is 1.05x, 26,355. Last step is always divide. X. 5,100? Thank you. Is that good? You guys getting that okay? With the calculator and everything? Questions on that one? So same kind of thing, right? Percent increase, percent decrease. Okay, so the worker, base salary of $160 per week plus 98 cents for each unit produced. 1 week the worker earned $383.44. All right, yeah. So what you need to do whenever they have like a base and then per unit, well, you know, huh? What I'd encourage you, if you read this kind of word problem and you're like confused, you have no idea, I bet you really do know if you'll just think about numbers for a second rather than X's and stuff, because X's can be confusing. Just think about numbers. What I mean is if I read a word problem like this and I'm totally confused, I learned to, in all the classes I used to take, I learned to just say, hey, what if it was 10 units? I would just think 10. What would I do with 10? And I can think better with a number. And then I would go back and then I'd do it with same thing with X. So what if somebody said 10 units? 10 units. How much are you going to get paid if they say we'll pay you $160 base and we'll pay you 98 cents per unit? So what would I get paid if I'm getting a 160 base and 98 cents per unit and I cranked out 10 units? How would I figure that out? You could all do that, huh? Very easily. What would you do? Yeah, I'd take what would I multiply? 0.98 by the 10, right? And then do what? Add to the 160. Exactly, right? Isn't that what you would do? Right? If I cranked out 10 units, I get 98 cents for each of those, so I would multiply 10 times 98.98. And then I would add my base pay, and I don't even care what the answer is. Whatever that came out to be, that would be what I get paid, right? So instead of using the 10, put the X in. That's the formula. See how that works? Just think what you would do with a 10, and I think you think better. We all think better with numbers than we do with letters. So just think with a number like 10, and then go, oh, okay, yeah, you just multiply by 0.98 and add the base. And what do we want that to equal? Yeah, that's the 383.44 that they did get paid. They got paid 383.44, so now we can solve for x, how many units. They didn't produce 10 units, they produced much more than 10. How many units did they produce? So let's solve for x now. What's my first step in solving for x?
Subtract 160.
The 160. So I get 0.98x, scribbly there, equals something.
223.44.
223.44, thank you. And last step is always divide by 0.98. And so is the answer, what is the answer? 224, 225? 228? 228 units. Does that make sense how I did that? I just said, well, however many units times 98 cents each, plus 160 base pay, is the total pay. Solve for x, 228 units. All right, so Malcolm paid $38 per tie for 3 ties on average. Let's hold up right there for a minute. So Malcolm paid 38 per tie on average for 3. He didn't pay 38 for each tie, but it's like he did, right? That's the average. Can we figure out the total amount Malcolm paid for those 3 ties? What could we do? Yeah. Does everybody see that just take 38 times 3, what, 90, 24, 114? $114 must be the total paid. Does that make sense? Because if he paid on average $38 per tie, right? So 3 ties, he must have paid 114 total, even though he didn't actually pay 38 for each tie. It's like he did. That's what average means. Huh? It's like he paid 38 for each tie. So we could multiply and say, well, he must have paid 114 total. So they're being tricky. It's just a tricky way for them to give you the total. He must have paid 114 total. That's not the final answer yet. He paid 114 total. And now, what else are we going to do? It says, can you read those words? It says, one tie was twice the other, and the remaining tie was $24. And that's off the screen a little bit. So one tie was twice the other. So one of them is X, one of them is twice that, and the last one is $24, and they add up to be 114. It's off the screen a little bit, huh? Squeeze that in. Do you see how I came up with that, guys? One tie, the other one's twice that, and the last one's $24, and they total 114, we figured out. That's tricky. They're being tricky on this one. So we had to first figure out the total by using the average fact. And then the one tie is X, the other is double that, 2X, and then 24 for 114. Does that make sense? How do we solve for X?
You added 2x and
Yeah, X and 2X?
3x.
3X. And next step, subtract the 24. What's that? 90, thanks. And last step is divide, like always, X is 30. So he paid 30 for one of the ties, that means. 30, so one of the ties was 30. So the ties were 30. What was the other tie then? Yeah, double that, right? So that'd be 60. So he paid 30, 60, and then 24 was the other one. $60 for a tie? My kids think I'm the cheapest person in the world, but it's not me. These prices are shocking. That's craziness. All right. Good on that? Makes sense?
What did you do right now?
Because they said one of them was twice as much as the other, once I had the first one as 30, I just doubled it. The other one must be twice as much. Must be 60, which is crazy price for a tie. Yeah. Soon. Very soon. Soon. We'll take the test. So, because I believe 8 is on the test. Did I get your attention with that? 8, I think. Yeah, I'm pretty sure it is. 8 is, that's not the one I wanted. There it is. All right, so 8 is on the test, I believe. I'm pretty sure. So let's do it. So, and 8's got a trick. I'm not meaning to trick you. It's I get these questions off the publisher of the book. They have like a test bank, and so sometimes they do funny way. I don't like the way they do the answers every now, well, especially on this one. So I want to show you. They wrote the answer a funny way. I'm just grabbing what they have. I just go out there and say, give me one of this type, one of that type, and then it makes the test automatically. So the publishers did this, and they wrote one of these weird. So let me show you, heads up, for what's going to be on the test today. All right, so what are we supposed to solve for? C. So how do we solve for C? What do you do when you got fractions? What did we learn? We call the hitman, right? Remember that? Who's the hitman here? Yeah, the only denominator is the hitman 5. And so what does the hitman do? You multiply every term by it. You with me? Whenever we have, so today's test, every time you have fractions, everybody, left side, right side, every term gets the common denominator. And what if there was what if there was like a 2 down here? What if there's a 5 and a 2? What if it was f over 2? Then what would I multiply everybody by? 10. 2 times 5. Then if you got 2 denominators, you multiply them together. 10. And I would go 10, 10, 10 instead of 5, 5, 5. Right? Everybody with me on that? Common denominator, you multiply. If there's more than one denominator, you multiply those together and then top, top, top. And then what does it do? It takes out. Remember, that's his job in life, is to take out. So let him do that. So then this is 5F, 9C, and these guys are going to multiply. What's that, 160? Choose your calculator. We're good to there somewhere. No more fractions. Much nicer. No more fractions. Everybody good with that first step? So there'll be 2 or 3 today that have fractions. Common denominator, top, top, top. Cancel whatever you can, like the middle cancel. Why didn't these cancel? Because the 32 is not under a bar. It's only things under the bar that cancel, huh? Right? The other ones multiply, right? The canceling is just cross-canceling. 5 over 1, it cross-cancels, high to low. Stuff under the bar, right? That's why we're doing it. We want to get rid of denominators. All right. Anyway, we're to here now. Keep your eye on the ball. C's here saying, I want to be alone. So whatever is with C, we save the 9 for last, right? You save the item right next to the C for last. Yeah. Right? Always save the guy right next to him. For your buddy right next to you goes last, right? Mm-hmm. Right? So it's like who was the famous Greek or Roman general? I'll try to give you I'm a wannabe history teacher. I hated history in high school, loved it in junior college. Too late to change my mind at that point. So I'm a wannabe. So every now and then, but I can't remember. I'm not really a history teacher, so it's kind of a lame half thing. So who was the one to say A2 Bruno? The famous saying, the guy that turned over the Roman Empire, and the guy that turned him in was his best friend in the end. And the famous statement was, and you, Bruno, was it Bruno or something like that? Brutus, thank you. Yeah, I'm glad you're here, Roberto. What did you say? A2, like and you, like even you, my best friend is.
When they stabbed him on the.
Yeah, that's it.
Senate.
Yeah, it's in the Senate, right? And Brutus was part of. It was like his best friend, and yet he turned on him in the Senate. All right, enough said. We got to do math here, but I'm really doing that to help you remember. Your best friend, the one right next to him, that one's last. Even like in history, right? It was Brutus last. All right. So if that helps. So subtract 160, right? So save the 9, save the thing right next to it for last. Get here, 5F minus 160. And now how do we get the C alone? Last step is always, not minus, last step is always divide, right? Boom. Now that's the right answer, but it's not there. This is why I really wanted to show you this one. We got to do this and we'll take the test. It's on the test tape. Now what are you going to do? This is the correct answer. That was perfect word. But it's not there. Now, don't be too quick to grab none of the above. There are some none of the aboves today, by the way. People always, I'll just tell you up front, after the test you go, Mr. Heron, I hate your none of the aboves. Everybody tells me that every semester, so it's fine. So 3 or 4, maybe 5 of them, I don't know exactly, are none of the above on the test today. I do use that option. Some of them are, but not like 10 of them, A couple will be none of the above. But don't be too quick to grab none of the above. Check it out. It really is one of these. But they're writing it weird. They're being tricky. Let me help you. Take that first one and distribute and see if it becomes the same as this one. It actually does. Let me show you. Grab this first one. The answer is actually that one. take 5 9. See, it's tricky. F minus 32. Boom, boom. You can put this on your 3x5 card right now if you want. You get a 3x5 card, right? You know, use the helps I'm giving you. Write it right now if you want on your 3x5 card. If you don't have one, make one quick. Rip out a piece of paper. 5 9 F minus, I'm just distributing that, right? 5 9 times F is 5 9 F. And 5 9 times 32. How do you do a fraction times a whole number? Well, that 32 is really over 1. So the 5 goes to the top. 5 times 32 is 160 over, and the 9 times 1 is on the bottom, 9. So it's 5 9 F minus, so I just took answer A, distributed the 5 9s, boom, boom. Use my calculator, 5 times 32 is 160. 5 9 F minus 160 over 9. See, that's the same as this. The 9, I put one big bar, but it's the same as having it on both. That's the same answer. But it didn't look that way at first. So I'm not saying it's A today. They're mixed up. There's a yellow and a blue, and they're all mixed up. It might be A, I don't know. But it's like that. It's like that. So it's a trick one, and I'm not wanting you to be tricked. That's the trickiest, weirdest one. The rest are more normal, I think. Yeah.
Okay, so that was my question, if the other ones were gonna be.
No, it's just that one. The rest of them, when you get an answer, you'll see it. It'll look normal.
Okay.
That's the one that they made it look weird, so I wanted to show you. Does that make sense? Should we take this thing?
So the other one will look weird like that too.
The what's that? Oh, yeah, it'll be just like that. I'm pretty sure that's on today's test. Yeah, it'll look just as weird, just like that.